Hi everyone. So the last thing we need to learn in this chapter is how to solve equations with logarithms. And this is where you're going to see sort of everything we've done so far in this unit come together. Everything that we've done on logs is going to sort of play together here. And then of course you'll use this even more going into next year. I'm going to throw an extra slide in here so you can jot this down someplace. And some of this comes up later in the presentation. I have a slide where it gives you like helpful guidance. This is sort of a repeat of that, but I feel like it's helpful information to have up front. But if you want to find a place to jot this down, somewhere it might be helpful. So the problem with solving logarithmic equations is that there's no set method. Okay? There's no like procedure. I can't say step 1 you're always going to do this, step 2 you're always going to do that. Okay, you'll notice that I think the first couple of slides I even point out that you have to be a little bit creative when you solve these. But you can sort of lump them into some general categories. Okay, so there's a couple of different approaches that you can take. The first one would be if you're solving or if you're simplifying and you come down to log of blah 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 equal to a number. Okay, so you have a log on one side and just a single number on the other. That would be sort of one general approach. If you get that, usually I find that if you rewrite in exponential form, you can solve it. Okay. So if you come down to like log of blah 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 equal to a number, and there will probably be, well, there will be an x in there someplace. You can try rewriting it as an exponent, okay? And then usually you'll have a way to solve it from there. The other thing you're going to run into is log of something equal to log of something else. So a log equal to a log. As long as the bases are the same, okay? And I can't imagine I would give one to you that where the bases weren't the same at this point in the game, but as long as the bases are the same, you can just cancel out the logs if there's one on each side. Okay, so if you end up with a log of blah 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 equal to a log of blah blah blah, you can cancel out the logs on each side. And then anything else, anything that doesn't look like one of those two things, I would simplify as far as you can using all those tricks that we've talked about, all of the rules about combining and dividing and all that stuff. Simplify it until it does look like either this one or this one. So sometimes you kind of have to do some work up front, but it's always going to come down to looking like either log equal to a number or log equal to a log. Okay. The other thing you're going to see is equations where it's like a number to the power of x is equal to another number. We actually worked with that yesterday, but we'll get into more detail on how to solve something like that later in the process. So right now we're kind of going to just focus on these two, okay? And then also this third one where you have to simplify to make it look like one of these. And if that sounds confusing, hopefully it'll make sense after we do a few examples. So none of this stuff is written in your notes. Well, it comes up a little bit towards the end. There's a slide where I give you like some helpful tips. This is sort of a recap of that, but I think it's going to be more useful to have up front. If you want to jot this down someplace, you could. When you're solving equations with logs, there's not like one set method. Okay, you can't just say, first I always do this, and second I always do this. All of the equations are a little bit different. But just as some helpful guidelines, there's sort of two different types of ways that you would go about it in general. So one would be if you end up with a log of something something equal to a number. Okay, so you solve, you simplify everything you can, and you come down to log of blah 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 equals just a number. In this case, I would usually rewrite in exponential form. Okay, so let's take, for example, this first one. says log base 2 of 3x equals log base 2 of 6. Notice in this one, you have a log on this side and a log on that side. Okay. Well, if they're both log base 2, hopefully it makes sense to you that if log base 2 of 3x has to equal log base 2 of 6, then 3x must be equivalent to 6. Okay, whatever this is, it has to equal this if they're both log base 2. Okay, so this would be a case where I can say, look, I have a log on this side, a log on that side. I'm just going to drop the logs. I'm just going to cross those off. That leaves me with 3x equals 6. And that I can solve just by dividing by 3. Divide by 3, divide by 3, and I find that x is equal to 2. Okay, so hopefully that wasn't too bad, not too painful there. Let's look here at the second one. Second one, very similar. I've got log base 5 of blah, blah, blah is equal to log base 5 of blah, blah, blah. Well, if they're both log base 5, then the two blah, blah, blahs, these, must be equal to each other. So again, because they're both log base 5, just ditch those. That leaves me with negative 2a plus 9 is equal to 7 minus 4a. And then I'm just going to solve from there. So I would probably, let's see, add 4a. I'm probably going to run out of space right here. That leaves me with, I'm going to go over here. Negative 2a plus 4a is 2a plus 9 equals 7, and this is gone. Okay, then let's subtract 9. Subtract 9. So 2a is equal to negative 2. Divide by 2, divide by 2, and a is equal to negative 1. Negative. Okay. So that's how that one would work out. Okay, now if I go down to this third one, yes, they're all log of 9s, but if you've got two logs over here on the same side, you can't just drop them off. You can't just get rid of them. It's got to be log of blah equals log of blah, like only a log and a log, okay? I can't work with something like this. But what I can do is think about this like we did last week Friday, okay, with the properties of logs, with the combining logs. So for now, pretend this isn't here. Ignore that log base 9 of 12. Pretend I'm just working with the left side. And I want to combine those two logs into one log, okay, so that I can have one log equal to another log. This is subtraction in here, okay? And remember, when you subtract logs, that means you're really dividing these two things. So I could take this left side and rewrite it as log base 9 of, and then this would be x divided by 4. And again, it's division because subtraction with logs really represents division. So log base 9 of x over 4 equals log base 9 of 12. So now I've got that situation where I've got a log and a log. I can cross that log off, cross that log off. I know that x over 4 must be equivalent to 12. Okay? So I would say x over 4 equals 12. And then I would multiply by 4, and you end up with x equal to 48. Okay, so that one took a little bit of work at the beginning. I had to combine those logs on the left side. But then once I got it in that log equals log form, I could just drop the logs off and I'd be good to go. Okay, so all of those were sort of that second situation of the little hints that I gave you on the last slide. All of these were that second scenario where you ended up with a log equal to a log. Okay, so now let's look at these. Okay, log base 3 of x equals negative 2. So this time I don't have a log equal to another log, so I'm not going to be able to just drop the logs off. But if I have just a log equal to a number, I could try rewriting it in an exponential form and see if that helps me at all. Okay? So remember, this is my base, So I would go 3 to the power of, here's my exponent, 3 to the power of negative 2 is equal to x. Well, I'm trying to solve for x. I want to know what x equals. Here's what x equals. X equals 3 to the power of negative 2, which if you type that into your calculator, you're going to get a decimal, which is fine. I would probably prefer it as a fraction. 3 to the negative 2 is just 3 squared, which is 9, and then the negative means put a 1 over it. So this would be x equals 1/9. And that'd be your answer. Okay? So sometimes when you put them in exponential form, it's as easy as this. All I have to do is figure out what that equals. Now looking at that next one, it's not quite as straightforward because I don't just have log equal to a number. Okay? I have this extra negative 10 sitting here. Okay? So before I can start anything, I need to get rid of that negative 10 there on the left. I need to move that. So I'm going to add 10. Okay. And so now I'm left with log base 3 of n plus 3 equals negative 10 plus 10 is 0. Okay, so now I have that form that I had up here. Okay, I have that log equal to a number, and now I can rearrange it and put it in exponential form. So in exponential form, this would say 3 to the power of 0 equals n plus 3. Okay, well, 3 to the power of 0. 3 to the power of 0 is equal to 1. Anything to the power of 0 is equal to 1. So now this says 1 equals n plus 3. Subtract 3, and I get negative 2 is equal to n. Okay, final answer on that one. Okay, so again, that one I had to do a little bit of work to clear some of the other junk out of the way, but once I got it to the point where it was log equals a number, I could rewrite it as an exponent and solve. Okay, so take a look at that next one. Negative 6 log base 3 of x minus 3 plus 5 is equal to negative 19. So what I really want to focus on with this one is here's my log, okay, that I want to have equal to just a plain number on the other side. So this negative 6 and this positive 5, I need to move both of those before I start. Okay, I'm going to start with the plus 5 because that's how we solve equations. We always get rid of addition and subtraction first. So I'm going to do minus 5, minus 5. So now I have negative 6 times log base 3 of x minus 3 equals negative 24. Okay, because negative 19 minus 5 is negative 24. Now to get rid of this negative 6 that's attached with multiplication, so I'm going to divide by negative 6, divide over here by negative 6, that's gone, and so now I have log base 3 of x minus 3. Sorry, my handwriting is kind of messy in here today. I'm having a hard time with this stylus. Negative 24 over negative 6 is positive 4. Now I have that situation that I like, the log equal to a number. So I'm going to rewrite it as an exponent. I'm going to put it in exponential form, starting with this. So 3 to the power of 4 is equal to x minus 3. Okay. 3 to the power of 4 is 81. So 81 equals x minus 3. And then if I add 3 to both sides, I end up with 84. So x is equal to 84. Okay? So all of those, after I did sort of that beginning work to simplify it, ended up in that first scenario I talked about where it was log of something equal a number, and then I rewrote in exponential form. So again, you have this printed in your notes. This is sort of a repeat of what I said at the beginning. I just thought it would be more helpful for you to see at the beginning. So this is talking about, one log in the problem. That's where you have log of blah, blah, blah equal to a number. And those are the ones that typically you want to clear everything else out around it, get rid of any extra numbers that are there, and then once you have log equal to a number, just that, you can convert to exponential form. If you have two logs in the problem, you want to make it so that it says log of blank equals, log of blank, okay? And then once you have it set up like that, you know that these two quantities have to be equal to each other, so you can drop the logs off of there and just solve from there, okay? And then if you have 3 or more logs in the problem, or if you have extra numbers, because we saw that a couple times too, where there was like, you know, hey, I multiplied by 6 out front, or I have a +5 on the end. You want to combine any logs that you can. You want to use your properties. You want to use just good equation solving to clear out some of those extra numbers. Basically, you want to simplify it any way you can until it looks like one of these two situations. Okay? On your homework, you're going to have a whole wide variety of the types of problems that you're doing, but I really encourage you to look back at the examples that we've done here, because you'll have an example in here of just about everything you're going to see in your homework. It's just a matter of lining it up, okay? A matter of finding the right one that goes with the example you're working on. Oh. Okay, this next method you actually saw yesterday, but I just want to reiterate it to you. If you have an equation like this one, okay, so there's no log in it at all to start with, but I've got an x sitting up here, okay, in the exponent, and I want to solve for x in that equation. This is sort of the process I go through. So first of all, you want to make sure it looks like this. It's something to the power of x equals another number. If you have any extra numbers sitting around, get rid of those first. So if you had like a +2 sitting out here, or a multiplied by 3 or something, get rid of those first. Then we're going to take a common log of each side, which lets us bring the exponent down in front using that powers property. And then I can solve by dividing the logs. So with a problem like this one, I've got it all cleaned up. Okay, so it's just a number to the power of x equals another number. I'm going to take a common log over here and a common log over here. So when I write that out nicely, it's going to look like this. Log of 5 to the x equals log of 12. Okay, so I took a log on each side. Now, I can take this x, and by that exponent rule that we have, I can move it down in front. So now my equation says x times log 5 equals log 12. And then if I'm trying to get x by itself, it's attached to this by multiplication. So to get rid of multiplication, I'm going to divide. So I'm going to divide by log 5, divide by log 5. This is gone. This piece I can put straight in my calculator, and I happen to remember from yesterday that this is equal to like 1.54. So that would be your value for x, okay? X and this one would equal 1.54. So when you're given an equation that has x in the exponent, you're going to take a common log on each side, okay? You're going to take that exponent and drop it down in front, and then you're basically going to divide by whatever log is left here. So let's try a couple of these real quick. I have 3 to the power of x equals 10. Okay, and I'm going to move this over so I have some room to write. Make sure it's in that clean form where it's just a number to the x equals another number. That's what I have here. So I want to take a log of each side. So I'm going to say log of 3 to the x equals log 10. Then I'm going to take my x and move it down in front. So now it's going to say x times log 3 is equal to log 10. Okay? And then if I want x by itself, I need to get rid of log 3, so I'm going to divide by log 3. So x would end up being log of 10 divided by log of 3, which equals, gosh, I don't know. Okay, track down a calculator, comes out to like 2.09. Okay, and always check your answer to see that it's reasonable. If I'm saying my answer is 2.09 and I go back to this original equation, okay, let's just say, that should mean that if I do 3 to the power of that answer, 2.09, it would equal 10. Well, let's see if that makes sense. 3 to the power of 2, which is really close to that, 3 to the power of 2 would be 9, okay? And that's awfully close to 10. So if I go just a little bit bigger than 2, that should move me up just a little bit and have it equal to 10. So, and you could certainly just plug this into your calculator and check and make sure. I mean, I had to round this number off, so it might not come out exactly, but it should come out awfully close to 10. Okay, so looking at that next example, this is what I was talking about when I said sometimes it's messy. I really just want this, okay? So I need to get rid of this plus 3 before I even start. So I'm going to start by subtracting 3 and subtracting 3 so that I have 5 to the power of x over here, and then this would be 56. And so now it's in that nice clean form that we like. All right. Now I can proceed with taking the log of each side. So moving up here, now this would say log of 5 to the x equals log 56. Okay. Let's slide the x down in front because it's an exponent, so I can put this down here. Make this x times log 5 equals log 56. And then I'm going to end up dividing by that log 5. Divide by log 5. Divide by log 5. That's gone. This piece I'm going to put straight into my calculator, which comes out to be equal about 2.5. Okay, is my final answer. And again, let's just kind of check that and make sure that makes sense. I'm just going to think back to like this statement right here, because this step I know we did correctly. So 5 to the power of x equals 56. Well, 5 to the power of 2 is 25. And 5 to the power of 3 is 125. So 56 kind of falls somewhere in between there, between 25 and 125. So I know I'm going to be somewhere between 2 and 3. This looks like a pretty reasonable number. Again, if you wanted to be more specific, you could actually plug that into a calculator and check it. But I usually just check to make sure it's reasonable, okay? Because usually if it's reasonable, it's pretty gosh darn close to correct. Okay, and the last one. 2 times 5 to the power of x equals 30. Do not combine the 2 and the 5, okay? Because the 5 is being raised to this power of x, the 2 is not. So I can't combine the 2 with the 5. I can, however, get rid of the 2 before I start, which I definitely want to do. So I'm going to divide by 2. Divide by 2, divide by 2. That's gone, and so now I have 5 to the power of x equals 15. 30 divided by 2. I'm going to take the log of each side, so I'm going to have log of 5 to the x equals log of 15. Okay, slide that up a little bit. Let's move that x down in front. So now I have x times log 5 equals log 15. I'm going to divide by the log 5. Divide by log 5. This is gone. This is going straight in my calculator, and I'm going to get an answer of 1.68. Okay, that's my final answer for x, which again, looking back here, 5 to the power of x equals 15. I know it's not even going to be 2, okay, because 5 to the power of 2, if this were a 2 right here, this would be 25. I need it to be less than 25, so I need my exponent to be less than 2, which this is, okay? So your homework sheet I gave to you yesterday, I will attach a blank copy of it in case you don't have it for whatever reason, but it's just, I think it says like logarithmic equation practice. And every example on there lines up with something that you've seen in this set of examples that we've done in the notes here, because there's a lot of examples here. So please do your best to try to line them up and make them correspond and do the best you can. And we will spend some time going over this tomorrow. Quiz Friday.